Hi everyone, welcome to this webinar on real-time big data analytics using Spark and Python. My name is Vinod Venkatraman and I am the head of technology here at Great Learning. And I'm very excited to have all of you on board as we explore what real-time big data analytics is and how you can use Spark and Python to actually go about doing this. So first of all, I would like to start with the agenda of this webinar. What are we going to cover in the next 1 hour? So the first thing that we are going to do is understand what real-time data analytics means. What is this and why is it relevant in today's day and age, and how is it different from the normal data analytics that you and I do. Post that, we'll move on to the use cases where real-time data analytics is being applied today, and why is it so critical to be able to do real-time data analytics, and what are the use cases where it applies. After that, we will move on to understanding how we can so every time you have a lot of data, you have to be able to model it in a certain way so that it is easy to analyze, right? After that, what we're going to get into is how do you analyze real-time data now that you've modeled it. So now that you've modeled data in a way it is easy to analyze, how can we actually go about doing the real-time data analytics? After that, we will get into Spark and a particular component of Spark called Spark streaming, which can be used to analyze data real time. And in the end, which is my favorite part, we are going to actually do a real-time analysis of tweets as they are happening during this webinar, and we are going to find some insights from all those tweets. Okay, so this is the agenda we're going to do. So let's get started. Okay, so what is real-time data analytics? Essentially, real-time data analytics is the ability to analyze data as soon as it is produced. So data is produced all around us, right? Every tweet we make, every social media post, every user visiting a page on our website, user purchasing a product on our e-commerce website. All of this is essentially data which is produced at different points in time. What real-time data analytics is the ability to gather insights from this data as soon as it is produced. So literally a 0 millisecond latency. Now, there is another term that is related to real-time data analytics, which is near real-time analytics. What this means is, data gets produced, but you are given a little bit of leeway. You can analyze that data within a given time frame. For example, let us say we have an e-commerce setup where users are coming and purchasing products. What I want to do is, in the last 1 minute, I want to find out how many products were sold, right? And this I want to do based on each event, which is the order placed event. So one after the other orders getting placed, and I'm doing a near real-time analytics where I am, I'm trying to count how many orders were placed in the last 1 minute. So near real-time analytics is essentially the analytics where we analyze data within a given time frame after it is produced, right? Now this time frame is dependent on the use case. The use case that we just spoke about is users placing orders on an e-commerce website, and there the business teams ask you to give a report every minute how many orders were placed. So the use case of analytics, which was to the 1 minute in which you had to count the number of orders, let us say, it will define the time frame in case of the near real-time analytics. Okay, so now we know what real-time data analytics is, and we also know near it is produced. Now I would like to take a little bit of time and discuss what is the difference between the traditional analytics, batch analytics that is done using Hadoop and MapReduce compared to real-time analytics. So if you take any large analytics deployment in any company, what happens is that data gets gathered. Like in this example, orders get placed throughout the day in the order management system of that e-commerce company, and a job will run in the night, which will pull data out of the orders table or orders database or whatever system it is, and import that data overnight into Hadoop or into HDFS or whatever. And then the next day, you will analyze all the data, the data that has come from the previous day or the previous week. So different use cases based on the amount of data you want to, analyze. Traditional batch analytics happens this way. So transactional systems produce data, though that data is at some frequency imported into analytic systems like Hadoop or or Spark even, and after that it is analyzed with a time delay, which may be days, which may be weeks. Whereas, as we know, we just discussed, real-time analytics or near real-time data analytics is about the ability to analyze data within a very short time frame from which it is produced. So having any, borrowing any procedures from these traditional batch analytics where a nightly cron job or something like that gathers all the data and imports it into your analytics system is not going to work. So I wanted to highlight this key difference, where traditional batch analytics systems, run once a day. They, they use Scoop, or they use some, HDFS copy tools from which they copy data from these transactional systems into Hadoop, and then the batch analysis runs the next day. Whereas real-time data analytics, which is the topic of today's webinar, the system that we build will need to have the ability to analyze data as nearly as soon as it is produced. Okay, so now just to summarize this, we have learned what real-time data analytics is, what near real-time data analytics, and the difference between traditional batch analytics and real-time analytics. So moving on, now let's look at a few of the use cases where real-time data analytics is required. The first use case is very simple. I don't even know if this is an analytics use case per se, but it's a real-time use case definitely. Let us say there is a system, that is deployed in the intensive care unit beside each bed in the intensive care unit, which is monitoring the key vitals of the patient, right? Such a system, the main decision it has to make is to raise an alarm in case the patient needs immediate medical attention. A system like this cannot work with the traditional, batch processing thing, right? Where you gather all the stats, then it goes to another system where a cron job runs every 5 minutes, which looks at the vitals and then raises the alert. Maybe the patient would meet with a fatality meanwhile, right? So in this case, like an ICU case where there is, as soon as you detect that the vitals are, the vital, metrics of the patient are going haywire, you need to immediately act on it. So that's one. The next is fraud detection in today's world. Today we are all doing online transactions. We enter our credit card details in multiple websites, right? So what if a fraudulent website somehow takes the credit card information from you and starts doing transactions on your credit card on your behalf? It's basically spending your money to buy things for themselves. So in finance or cybersecurity, it is very important to detect these frauds real time or near real time, because there is no point having all this data gathered overnight and next day analyzing what all fraud happened. The fraud has happened, the money is spent, and now you have to reconcile somehow, right? Or you have to go for your insurance to reclaim the money. So essentially, in the cybersecurity space or in the finance space, fraud detection is a use case which demands real-time, analytics of financial transactions, so to say. The next is you have an application that you have deployed on the cloud. Let us say you have built a website that you have deployed on the cloud. How do you know whether it's working right now, right? How do you know, in the last 5 minutes or last 2 minutes, how many error pages, did it serve? How many times did it fail? So these are again things, if you don't act immediately on, your application's health, then it might cause widespread impact on your business. So again, application health monitoring, which monitors how many errors you are serving to your end users, how many, page load errors, 500 errors, all of that needs to be real time. The next is, nowadays, it's all about every business is moving towards data-driven decision making, and one of the aspects in that is, let us say you roll out a new feature on your website, and then people start talking about that feature in your product on social media. You want to know quickly. You want to know as soon as the feature rolls out, what is the user sentiment based on social media? What are they tweeting about? What are they talking about on Facebook? So again, there, if you do the traditional batch analytics thing, then you'll come to know maybe a day or two later, and by that time you could have impacted maybe 90% of your users. They might have loved it, it, which is all good, but if they disliked it, you could not prevent it because your system was not geared to analyze data as soon as it was produced. The next is, Google Maps. I want to go from here to, I want to go, go to some place. Google Maps uses live traffic management, right? So it is looking at traffic data as it is produced, and based on that, suggesting which routes are best in terms of time, which routes are less congested. So that's another use case where Google Maps in this case has to act on the traffic information real time and then, suggest better routes. The next is high frequency stock trading. So let us say there is a system which, whose responsibility is to automatically using an algorithm, invest money into stocks, buy stocks and sell stocks, so that at the end of the day, it has made a margin, it has made a profit for its users. Such a system, has to act quickly because stock prices, raise and fall within seconds. So if a system like that, looked only at historical data and could only act tomorrow, today the company might be doing very well, but tomorrow, by the time it analyzes that data and decides to buy that stock, it might be too late, right? And the stock would just be falling the next day. The last, and something that we are all going to experience in the next 10-15 years is self-driving cars. So self-driving car is not a real-time data analytics per se, it's like real-time data processing. Self-driving car has to look at, whether it has to accelerate, brake, slightly turn left, completely turn left, turn right, all of that, right? So it has to be able to act on data as soon as it gets it or it gathers it. So these are a few of the use cases that I wanted to impress on you guys, where real-time data analytics is now not only a good thing to know, it's now an essential thing to have in your analytics toolkit. Okay. So moving on, what I want to talk next about is, we are talking about all this real-time data getting produced, right? Data getting produced and you needing the ability to process it real time. But how can you model this data in your minds so that you can understand how to do analytics with it? This is what this slide is going to cover. This is what we are trying to discuss here. So one approach, one way to look at data as it is getting generated is essentially as a stream of events, right? Or a stream of data. So data, real-time data or data getting produced at different points in time can be looked at as a stream of events. It's like a stream, a river flowing right in front of you. You're standing here and there's a river flowing right across you, right? And what that river essentially has, it has events, where each event in itself knows the timestamp of when that event occurred, and it also has the actual data inside it. So the model we are thinking of is, we are standing and there's a river flowing right across us, and it's a river of events. And those events essentially have in them the time when they occurred and the actual data of the event. So let us keep this modeling of data in our head so that we can see how we can tie this with analytics, or if we model the data this way, how analytics becomes slightly easier to do in real time. Okay. All right, so now moving on, what I wanted to next talk about is, what is the types of real-time data analytics that gets done generally? What are the different ways in which real-time data gets analyzed? So one common use case is for you to aggregate stats from recent events. Let us say, in the case of the example that we discussed, in the case of a website that you have deployed on the cloud, I, being the architect of that system, care about how many page load errors did it serve in the last 5 seconds, right? This is very important for me because only this can tell me whether my system is right now doing good or not, right? The other use case where aggregated statistics from recent events, can be, is needed is, let us say you work in an e-commerce company or in any company, and which sells different types of products. And your CEO asks you, okay, tell me how much revenue each category of products that we sell, like apparel, like footwear, like maybe books, like whatever else, how much revenue each of these categories is generating every minute, and I want it as latest as the last minute. So revenue per category in the last minute. And this again moving on, right? Every minute you have different data. Maybe this minute books are very hot, books sold a lot. The next minute maybe a footwear or a footwear promotion went live, because of which people ordered a lot of footwear. So then the next minute, your revenue per category for footwear would be higher. So one type of real-time data analytics is getting aggregate stats from recent events. The recent events is the real-time part. Aggregated stats is the analytics part. Okay. The next type of real-time data analytics which is done is essentially applying a machine learning model on this stream of events. So let us say, Amazon or any e-commerce website, let us say offline builds a model which, based on what the user is doing on the website right now, can predict whether he will actually go ahead and make a purchase in this session or in this interaction with the website. Let us say a model like this is built by all the the machine learning gurus at that company. Now, what you essentially want to do is, at any point in time, take the events that users are doing on your website, that stream of events, and put this machine learning model on top of it, and see how many of those people are just window shopping versus how many of them are actually likely to make a purchase soon, right? So that is one other way in which real-time data analytics is done, is you build offline models, machine learning models, for certain business problems, and as these events happen, you basically run these events through the model to predict or to figure out how many users in this case are window shopping versus how many users will actually make a purchase, right? The other type, the other way where machine learning models can be applied, another use case is the high frequency stock trading. So there is a machine learning model which says that if a stock, price change, if a stock is of this type of company and if its price changes by this much amount, then you should go ahead and buy this much quantity of that stock. Now, as the stock prices keep changing in the stock market, those are the raw events, that is the river of events. And this is the model that is sitting in between, which is making a decision to whether you should go ahead and buy the stock or you should sell the stock or not buy at all, right? So the second type of real-time data analytics is building offline models using the traditional batch-based analytics that we spoke about. Take those models and put it on this real-time stream of data and use it to make business decisions. The third and very interesting kind of the type of real-time data analytics you can do is basically, as the stream of events are happening, you actually build your model with that data, right? So the second example, the second type we discussed here, models were built offline, and then they were put on top of this river of data, the stream of data, and it was making some business decision. But what if your model has to be very recent? Your model cannot be a day old. It cannot be even an hour old. Maybe your use case, your business, the data that you're dealing with is very, very sensitive to time, and the model has to be built on the fly and used on data coming immediately after. So let's say you build a model based on gathering data for 5 minutes and use that to predict for the next half an hour. Then again the stream is flowing, you again build a model for the next 5 minutes, build a new model for the next 5 minutes and use it for the data flowing for the next half an hour, right? So these are the, in my head, these are the three types of, real-time data analytics that I have encountered. One is getting aggregate stats from recent events. The other is applying offline machine learning models on this stream of events. And the third is if your use case demands it, build the model using the recent data and use it to predict data that will come next, right? Cool. Right, so now we have essentially covered the basics in terms of what is real-time data analytics, how is it different from traditional batch processing, and how can we model data as a stream of events so that we can think about how to do real-time data analytics. Now let's come and discuss how Spark streaming enables this. How with Spark streaming you can do real-time analytics. Right. So essentially what Spark does is, do the exact modeling that we spoke about. It basically asks you to point it to a stream of data, and it models it as a sequence of data sets. So the stream of data that you point it to, it will start, receiving events from that stream, and what it will give out is a sequence of data sets. And each data set is essentially sequenced by a time frame. Or in other words, each data set is basically events from the last X seconds, or last 5 seconds, last 10 seconds, last 5 minutes, last 1 hour. Again, the real-timeness, the near real-timeness depends on the use case. So you tell it, okay, for me, this is the stream of data, and I want you to, give me a stream of data, a sequence of data sets where each data set contains data from the last X minutes or last 5 seconds in this case. So now what we have taken is we have taken a continuous stream and we have, in a way discretized it. We have made chunks out of it, logical chunks, one after the other. And now that the stream of data has been converted into a sequence of data sets. And how much data goes into each data set is defined by you in terms of how much time you want Spark to monitor that stream. In this case, events in the last 5 seconds, if you say that, then it will collect data for 5 seconds, that will be your first data set. Then it will collect data for the next 5 seconds, that will be your second data set. Then it will collect data for the next 5 seconds, that will be your third data set, and so on. So essentially, we have taken a continuous stream and discretized it into a sequence of data sets. Now, once we do this, you will see how each of the 3 types of analytics that we wanted to do will become easy. We'll discuss that in the slides. But moving on. So essentially, we have taken a continuous stream and made it into a sequence of data sets. What Spark does, as I explained, is collect data into the corresponding data set as it arrives. Now, and what it then lets you do is it allows you to analyze each data set as soon as its time window expires or as soon as it's full. So as soon as 5 seconds have lapsed in this example, your first data set in your stream will be ready. So you can then do whatever analytics you want to do on that data set. So essentially, it is enabling near real-time data analytics. Right? So we have the stream of data. We told Spark monitor it for every 5 seconds and give me a data set after data set every 5 seconds. And then what it does is it creates those data sets and it allows you to work with those data sets. It allows you to work, write code which will run on each of those data sets to do different things. And what are the things we could do? Going back to the previous slide, on each data set, we could find aggregate stats like page load errors in the last 5 seconds. On each data set, which internally has the raw events aren't lost, they are just grouped, discretized, put into a bucket. On each of those buckets, we can apply an offline built machine learning model to predict if this user will make a purchase. Or in the third case, we could use each bucket, build a machine learning model on the fly and apply it on the subsequent buckets. Right? So we took the 3 types of real-time data analytics we learned, and we saw how Spark's way of transforming the data stream into a model of into a sequence of data sets will allow you to do all those 3 types of analytics. Okay, these data sets, each data set is called a Spark RDD, and RDD stands for Resilient Distributed Data Set. So essentially, Spark is a distributed computing framework. So these data sets are not kept in the memory of one machine. These data sets are held by a cluster of servers, right? So some servers will have the first data set, some servers will have the second data set, some will have the third data set, right? And as these data sets arrive and they are ready for processing, you can send arbitrary code to work on this data to extract your insights. Cool. So now what we have understood is how Spark streaming is, allowing you to take a sequence of data flowing and convert it into a stream of data flowing and convert it into a sequence of data sets, each of which you can work. So that is how, real-time data is actually modeled in Spark as a sequence of RTDs. Cool. Now that we have these this sequence of RDDs, what is it called? So Spark calls it discretized streams. So basically, a stream with boundaries drawn. Boundaries first 5 seconds, next 5 seconds, next 5 seconds, so on and so forth. So that is what D-streams is. D-streams is a Spark streaming concept. And essentially, when you point Spark to a stream of data, it will give you a D-stream. Now, what can you do? at a 5-second interval as they are getting placed. So I'm an e-commerce company, orders are getting placed. That's the raw river. That's the event stream, the raw event stream. On top of it, I created a Spark D stream by saying collect 5 seconds worth of orders and create a D stream out of this raw stream. So now I have a sequence of these RDDs, which is the D stream. Now what can I do with it? I can transform it into a new stream, new D stream. And the functions it provides are available on the website. The popular ones I've just listed here. You can use the map function, for example, which will take each element inside a D stream, which will take that as the input. And whatever you output, that element will be replaced by that new element. For example, let us say I want to only look at orders which are worth more than 1,000 rupees. So I have the the D stream of orders. I map and pass it a function which will filter. The example I'm talking about is filter. Sorry. So with the filter function, you can essentially filter out events in the D stream which are greater than 1,000 rupees. In that case, the stream is left only with orders which are less than 1,000 rupees. What you can also do is do two streams. One may be a Twitter stream, one may be a Facebook stream, and combine both of them using the union. So you took two D streams and combined into, it's like taking two rivers and combining into a combined river, right? You can also do reduce, where you're actually counting how many, running a function which will, compare two elements and give one element back, right? So the D streams can be transformed into new D streams, and these are some of the popular functions. If you're not getting each of these functions, do not bother. When we go to the code walkthrough, we'll actually see each of them in action, right? So D streams can be transformed into new D streams. The other thing you can do is you can take this D stream and you can actually output it. You can save it somewhere so that you can, maybe you can output it so that you can maybe visualize it. Maybe you can analyze it so that you output it so that you can analyze it later, and so on, right? To do that, it also provides output and save functions like print, which just prints 10 elements per RDD in the D stream, right? So you have a D stream of orders. If you say .print, it will just take 10 elements from each of the underlying RDDs, the first 10 elements, and just print them out for you. So you can see, okay, this is the data that is flowing through the stream. Next, you can save them as Hadoop files so that each you have a sequenced orders all saved as files, one after the other. So all the orders placed in the first 5 seconds become one file. All the orders placed in the next 5 seconds become another file, and so on and so forth. It also has a very generic for each RDD function where you can pass whatever logic you want to do with each RDD. For example, let us say you wanted to report all these events to another analytic system like Mixpanel, or maybe save it to a relational database like MySQL or Postgres for some reason. Then you can use the for each RDD function provided on D streams and write your logic of opening the connection and sending the data to the relational database or do whatever with it. This is the most generic way in which you can output an RDD for each RDD, right? So just to take a recap, what we have learned is how Spark streaming models data so that you can do real-time analytics on it, which is basically a D stream. And now we have learned what can you do with these D streams. You can transform a D stream into another D stream, or you can output a D stream, okay? All right, so now we have had a lot of theory, we have spoken about modeling, we have spoken about Spark, Now actually let's do a hands-on example where we look at some code and actually do some real-time analytics. So the example that we're going to do in this hands-on exercise is essentially we are going to live stream tweets from Twitter which contain the word India in it as they are happening. So this will be a live stream of all the tweets which are happening on Twitter which have the word India in it, and then we will use Spark streaming to find out top hashtags in those tweets every 10 seconds. So basically it's in a way every 10 seconds we are finding out what are the trending hashtags for the window of 10 seconds. So right now maybe something is trending and maybe a news breaks and then something else will be trending. So we are actually on top of things as they are happening, and every 10 seconds in this case we're looking at all the tweets made about India and trying to find out the top hashtags in those tweets. When I mean top hashtag, I mean the most frequently occurring hashtag, the one which is mentioned in most number of tweets. Okay, so the example is very simple. We are going to connect to Twitter. We are going to ask it to send us all the tweets which contain the word India. Then we are going. This is that stream of events, right? Then on this stream of events, which is the tweets containing the word India, we are going to use Spark streaming to actually every 10 seconds find out the most common hashtags in that 10-second window. Okay, so let's get into the code now. Okay. Right. So the first thing we need to do in this example is to set up that stream of events. So for that, we are going to, first we're going to be doing this entire hands-on thing in Python. And what I'm using here is an editor called Canopy, which I would recommend to all of you as the editor to use for Python when working with, in general, it's a good editor. And what I'm using here is a package called Tweepy, which is Twitter for Python. Tweepy. What it allows you to do is essentially use the streaming API that Twitter provides. So Twitter provides you this API where you can, connect to make a call to Twitter and ask it to send you all the tweets with the filter which contain the word India in it. So line number 46 is the main method of this Python program, where we are first doing some authentication stuff so that Twitter knows who I am and why I'm accessing. You need to create a Twitter app for this. I would not get into all of that. So assuming all these two lines of code is boilerplate, what I'm essentially doing is after I am authenticated to Twitter, I am creating a stream and I'm asking a Twitter stream of tweets, and I'm asking it to filter it and give me only tweets which contain the word India in it, right? And this is what I'm setting up here. And what I'm setting, and whenever data is received, this is the function that will be called. So this is what TweetPy does for you. Twitter for Python, this is what it does. It provides you this ability where you can, connect to the Twitter API and the streaming API of Twitter in this case. And then whenever data is available, it will call the onData method. What I'm doing when I receive a data, this data is essentially the tweet object. So it contains the actual tweet, which will have the hashtags in it. It will also give when the tweet happened. It will also give, who tweeted, all of that, whether it's a retweet, all of that will be there in this data element. So for each tweet which has the word India in it, this function will be called. And all I'm doing here is printing it on the output. So let's actually first go ahead and run this program and see what are the tweets that are happening right now. Right, so yeah. So the file that we looked at was twitterstream.py, and that is what I'm running here. And when I run it, it's basically printing each of these tweets. So I can just stop it right now. So this is the tweet object that it has given me. And there is this text portion in it where the actual tweet is there. This is the actual tweet till here, the highlighted portion, right? So these are all tweets, which are having the word India in it, and that is what that stream is. So these are tweets as they are happening, by the way. These are tweets that are happening right now. So this is that stream of data that is flowing from Twitter, right? Okay, good. So now that we have, an idea of how to create a stream, in this case from Twitter, but in reality, you might not necessarily need Twitter, right? You might need something else. So there are many types of connectors that Spark streaming provides, with which you can connect to different data sources and create a stream out of it. One of the most popular sources is Kafka. So Kafka is a distributed, system where you can keep time series data, and you can easily use Spark streaming to connect to Kafka and get a stream of events, just like here we are getting it from Twitter. Okay. So this is a very simple example. This is this code I have, it's very simple. Essentially what we're doing is connecting to Twitter, asking it to give a stream which is filtered by the word India. And then when each tweet is received, we are writing it on the std out, which is what is happening here. Right. So the tweets are coming and they're getting printed out. So now what we want to do is point Spark streaming to this stream so that it can connect to this stream, and then we can do some magic with Spark, which is finding the top hashtags. For that to do, essentially what we need to know is where all can Spark connect to. So obviously this is not Kafka, this is actually a stream that is on the output of a process, so std out of this process, because we are just writing it out. So to actually make it more meaningful, what I'm going to do is essentially output of this, instead of printing on the std out, I'm going to send it to this part, this server, to this port on my local host. So essentially I'm taking all that output, and instead of printing out on the on the console, I'm actually redirecting it to the port 9999 on my local host. And then there is a port ready which has data flowing in, which easily we can connect from Spark streaming. Okay, so now let us go to the second part of the code, which is actually the Spark streaming part. It is there in this file, trendingtags.py. Okay, so this is where we'll be spending a lot of time. The stream is just, most of the times you'll find a connector for what you want. In this case, for Twitter, we had to do a little bit of coding, but most of the times you will normally, access data in a Kafka cluster. And Twitter has, Spark streaming has, support to connect to Kafka natively. It has built-in support, so you won't have to write this code. Okay. So now what are we doing here? So essentially here, our task is simple. We have that stream of tweets coming in on that port. What we need to do is first connect to that port, right? So essentially what we are doing, first I'll give you a top level overview of this code, and then we'll go a little deeper, right? So so this is the main program starting from line 24. So what we're essentially doing is, when you run this program, you give the host and the port where the stream is available. In our case, it is localhost, and it is available at the port 9999, because that is where we are writing it to. Because that's where we are outputting the stream to. So localhost on port 9999. Okay. So now what we're doing is creating a Spark context and giving it a name, so that on the Spark monitoring dashboard we can see our application, because this is a real-time application, right? So it'll keep running, and it'll keep telling you every 10 seconds what are the popular hashtags. So there should be a way to monitor it remotely. So that is why when you create a Spark context, you give an app name, and after that the window interval that we have chosen is 10 seconds. So every 10 seconds I want my analysis to be done. So I've defined a window interval of 10 seconds, and I've created a streaming context using the Spark context. So essentially, when you want to do streaming or real-time data analytics using Spark, you will have to create a streaming context, and to that you pass your Spark context, and you also pass the window, the time interval, how much time should it look at those streams, and then create those D streams out of them. So that is 10 seconds in our case. So I have created the Spark context here. After that, what I am doing is I am telling the Spark context to connect to the local host, which will be the first argument we'll pass, and the port 9999, right? So then now what we are doing is we are connecting, we are pointing Spark streaming to that stream that we have created in the using the Twitter stream Python file, right? So now the Spark context is being pointed to that stream, and what it will return you is a D stream, right? So when you point Spark to the stream of data, it returns you a D stream, which in this case I've named as tweets discretized stream, tweets D stream. And now we can play with this D stream. So essentially what am I doing here? We will go one by one. So what I'm doing is, first of all, as I said, you could take a stream and D stream and transform it into another D stream, which is what we want to do. So if you look at this output that we are getting JSON objects. These are all, these are all JSON strings, one after the other, that are getting printed. Right? This is a JSON string, and what I want to do is essentially look at the text part of it, right? And I want to, so what I'm doing here is taking the stream of JSON objects and converting it into a stream of, a stream of JSON strings and converting it into a stream of JSON objects. To do that, what I'm doing is running a map function with which I can transform the stream. And for each tweet, tweet, I am calling a function extract the tweet text, which is the actual text of the tweet. And I know that these strings that I'm getting, each line that I'm getting here as a tweet is a JSON object. So I'm just parsing that into JSON. And what I'm doing in the extract tweet text is essentially, if there is text in the tweet, get the text, else return an empty string. So this was to do some error handling. Essentially, I was getting some tweets in my stream which were not having any text in it at all, in which case this was breaking. So essentially, I wrote this function which will take that JSON representation of the tweet and return the text portion of it, right? The actual tweet. Okay, so coming back here, so what we're doing here is extract the actual text from each tweet. So we are taking one stream, calling the map function on it and transforming it into another stream, where instead of JSON strings, I now have the actual text of each tweet. Now after that, what I want to do is find out the hashtags from it. So essentially I am, next what I'm doing is I'm taking these text of each of these tweets and I am splitting it into words. So I'm splitting it by the space character here. So once I do that, it'll emit all the words in that string. So now I've done another transformation. So the first transformation happened with the map call. The second transformation is happening with the flat map call. So flat map essentially is very much like a map, but with the ability that for each input record, you can output multiple records. Whereas in a map, for each input record, you can output only one record. So its map is a one-to-one transformation. Flat map is a one-to-many transformation, right? So in this case, because I'm splitting the text into words, each text will have multiple outputs, each word in that tweet. That is what I'm doing here. Emit all words in the tweet. Now, because I'm only interested in hashtags, I'm using the third transformation where I'm filtering, these words that are flowing from this step to this step, and I'm, limiting them to only hashtags. So whatever word starts with hash. And then now I have a stream of hashtags. What I'm doing is, lower casing it and emitting a tuple. So in Python, what you can do is anything you put into brackets like this is called a tuple. So for each of the hashtag, I'm lower casing it and I'm emitting one with it, which represents that I've seen this once. So that when in a distributed environment, I can reduce all these ones, add all these ones up and count how many times this hashtag has occurred across the data set. Okay, so I'm emitting a tuple of word comma one here, and one represents that I've seen it once, right? And then I'm doing a reduce by key. This is another transformation of D stream to another D stream. So now at this point, what does my stream contain? It contains lowercase hashtags and one, this tuple. It's a sequence of this tuples, right? Word, hashtags and one, hashtag and one, hashtag and one. Like this, it's a stream, it's a D stream. What I'm doing is I'm taking two elements and I'm combining them by adding up their values. So I'm adding these ones where the value is same. That is what reduce by key does. So for a given hashtag, let us say hashtag India, all the ones will get added, and I'll have a composite tuple saying hashtag India occurred 1 + 1 + 1 + 1 + 1, which is probably 6 times, right? And that is what this reduce by key does. So count how many times each hashtag occurs. And now, till now what have we done? Okay, let's take a step back. We have taken a stream of JSON strings that Twitter was giving us. In the first step, we converted that into a stream of only the actual text of the tweet. Then we converted it into a stream of each word in all those tweets. Then we filtered it and converted it into another stream which only contained all the hashtag words. Then for each hashtag, I emitted a tuple saying I have seen this hashtag once. So tuple contains the hashtag and one. Then I am reducing by key. So wherever the key is same, the values how many times each hashtag occurs. But now our problem doesn't end here. So now we know all the hashtags and how many times each of them occurred. But we are interested in the top 10 hashtags, let's say. We want to look at the top 10 trending hashtags every 10 seconds. What that means is I have to now further order all of these, do an order by, and pick the limit 10. So essentially here I will be, till now what we have used is ability to transform the D stream. Now what we are going to do is essentially save each of these, the final transformed D stream as a table so that we can use SQL queries on it using Spark SQL component. So what we're doing here is now for each of these, hashtag, which now a tuple which contains the hashtag and the count, how many times it occurs, I'm emitting an object called tag count with the name of the hashtag and the number of times it occurs, right? So now my stream is transformed from a tuple of hashtag and count to a stream of tag count objects, Python objects, right? Where the tag count contains two things, the actual tag, hashtag, and the number of times it has occurred. Once I have this structured data, I can easily use the output function that we discussed. So there are two things you could do within D stream. You could transform and you can output. So now I'm outputting it into a SQL context, to a data frame. So I'm saying for each of these RDDs that are there inside the stream, run this function. So I get this RDD, I convert it into a data frame, and I save it as a table with the name tag counts. The reason I'm saving it as a table is then I can periodically query it and then output the top tags, right? So after that, if you see, for a second, just ignore these two lines, we'll come back to this. What we're doing is now we have done all these transformations on our tweet stream and finally saved it into a SQL context with the name tag counts. So now what I'm doing is I am just 100 times I'm running a while loop where I'm sleeping for 15 seconds. The reason I'm sleeping for 15 seconds is I have told Spark to collect data for 10 seconds. So it will collect data for 10 seconds. Then it will actually do this magic, this transformation and output on it. And then I will wake up after 15 seconds here and I will, query the same context, the tag counts context with this query. Select tag comma count from tag counts, order by count, descending limit 10. Essentially, this is an order by query limit 10 to find the top 10, tags. And I'm just looping through it and printing it, right? So just to recap, what we have done is we have created a Spark streaming context, pointed it to that stream, then instructed Spark that every 10 seconds, that is the interval with which I want you to create the D stream. And after that, on each, on the D stream, do this transformation and then do this output. And the output in this case is into a Spark SQL context so that we can run a SQL query to find the top tags. After which my client program, this is the client program, what I'm doing is connecting to that SQL context that we created with the name tag counts and running a SQL query on it. And then just printing out the results, okay? So now, if you look at the structure of this program, here we described what to do with the D stream. Here we described what to do once the D stream is saved to this context, to the SQL context. But Spark won't do anything till Spark streaming won't do anything till you actually start the context. So start collection of data with this call. Here you set up what all to do. You told Spark, okay, these are the things I want you to do on the D stream, but it won't do anything till you actually start the context. So once you do this, Spark engine is now collecting data from that stream on each, doing this transformation. And then our client program is just looking at the output that you saved here in the transformation and, printing out the hashtags. And then it is awaiting to be terminated. Okay. So that's the broad overview of what this is about. Now, let's actually try to see this in action. Okay. So I'll just pull up two windows. So in the first window, I am going to do essentially run my Twitter stream thing, which is going to create that stream and output it to this to the local host at this port. And on the other terminal, I'm going to actually submit this program, this client program that we wrote, where we told Spark where to look for the stream, what to do with the D stream, and then finally query the SQL context and print the top hashtags. So this is trending tags.py. So I'm going to submit it to Spark using the Spark submit command. I am giving it the trending tags.py file to submit to Spark, and I'm also giving it the host and port, because that's what this script requires. If you see in the script, we are when we are connecting to the stream, we are using the first argument as the host and the second argument as the port. So that is why there is this local host and the port, right? Okay, so let us start both of them. So what the left side window is doing is actually creating that stream based on Twitter. What the right side is doing, it is taking that stream and doing all the transformations on that stream, and then printing the top hashtags that are happening. So once in every 15 seconds we should see an output. So this is after 10 seconds Spark job actually running. That was that came on the right screen. Okay, and then there is an error, which is fine. Let me look, what is it? Okay, tag counts. Okay, let me just restart it once again, try it. That's the Spark job running, and now our client program should query to the table and get the results. Yeah. Okay. So essentially, in the first 10-second window, these were the trending hashtags: Startup India, Bank Bazaar, RPFC, Startup. So look like Startup is trending there. And now, here there are a couple of tweets with India in it, one about emergency, one about Aadhaar failure, Swachh Bharat, of course, right? So every 15 seconds, we are peeking into the data that we created using Spark streaming and printing it out here for us to visualize. Right? So essentially what we're doing here, let's take a step back, right? What is this overall streaming analytics we're doing? We're essentially streaming tweets in from Twitter, which contain, the word India in it. Then, we are pointing Spark to that Spark streaming to that stream and asking, using this transformation of these streams and the output functionality of these streams, we are saving that into a SQL context. And then we are peeking into the SQL context once in every 15 seconds and printing the top trending hashtags. So Ayurveda and yeah. Cool. So that essentially is all the things that I had for you guys. Let me actually just, maybe let it run once more, and then we can move to questions. Yeah. Okay. Okay, so I'm just going through the questions. So one of the questions is, where does Spark store data? So Spark essentially has a concept called RDDs, and RDD essentially stores data. So Spark is deployed on a cluster of machines. There are many machines which run Spark. So what Spark does is it utilizes their memory as well as disk to store RDDs. So to you as an end user, RDD is just like a data structure on which you can do map, you can do reduce, and so on and so forth. But internally what Spark does is it uses all the memory of the nodes on the cluster as well as the disk to store these RDDs. So to you, it is like rdd.map, you say run this function on it. But internally, it knows where is this RDD, which hosts are hosting it in the cluster. It will send that code to those nodes. It will run, and that will create a new RDD, right? So that is how Spark stores data. Okay, okay. So the other question from Dheeraj Singh is when can we choose Spark or Python script? So I guess what you're referring to is doing data analytics with just Python versus doing data analytics using Spark. So I would advocate, whenever your data is, small enough to, to be that you can bring it to your laptop, you should use raw Python and use scikit-learn and NumPy and pandas to do analysis on it. But when the data itself is big, and in this case, I have only used, a hashtag of, India. Maybe if I expand the hashtags that I'm filtering on, I might get a lot of tweets. Maybe I might get, maybe 1 lakh tweets per second. In that case, my machine alone cannot process it, right? In that case, I need to use multiple machines to do this analysis, which is what Spark gives you. So in this demo, I have actually run it on my laptop. But in reality, when you submit this job, you do Spark submit, you would actually submit it to a cluster of where Spark is hosted. And all of those servers will process those 1 lakh tweets per second to figure out which are the trending hashtags. Yeah, so there is another great question by Ajit who's asking, is Spark good for real-time analytics, or should we prefer Storm and Kafka and all those things? So the beauty of Spark is it is a package. It is not just real-time analytics. It is basically, it can do map reduce kind of jobs, the traditional batch processing. It provides you machine learning library with which you can do machine learning on distributed data sets, which is the replacement for Mahout in the Hadoop. And it also gives you Spark SQL, which is what we use today. We also use Spark SQL, where you can look at your big data, and query it using SQL syntax. And it also gives you Spark streaming, and all of that with one abstraction called the RDD, right? So essentially, Spark, the reason Spark is getting so much adoption, according to me, is the unified interface and the simplicity. Just look at this code. This code is literally so simple. It's like, that's it, right? And it is, I did not have to learn too many new concepts to do streaming. The only concept it introduced was, the D-stream, and everything else was, very natural, because the programming model is built on top of the Spark core. So it is not about Spark good for real-time analytics. I'm saying Spark is a very good big data tool in general, because it is giving you a lot of things, not only starting from ability to map reduce, then to the ability to do Spark SQL, then to do machine learning on big data sets using Spark MLlib, and then also to do real-time analytics like this. So yeah, so Storm and Kafka is another popular combination used to do real-time analytics, but I think Spark is getting more and more popular because the people who do real-time analytics are the same people who do, who write MapReduce jobs, are the same people, people who build the machine learning models, and Spark is that unified platform for them. All right, folks, thanks a lot for attending this webinar. I had a great time, and I hope you guys also had some takeaways and understood how we can use Spark and Python to do real-time data analytics. Thank you so much. Bye.